Now you will notice that over here, I had written this one. I noticed that it looks so long. So there is a solution to that. How do we solve that problem? We now try to write the numbers as product of their prime factors in index form. So the big question now is, what is an index? The concept of index is a concept that you need to understand very well in your grade 7, because it's a concept that you're going to be playing with a lot in your grade 10. In fact, the first topic, the first true idea you get to study in your grade 10 is a matter of indices. So your understanding of the context of index form here would help you then. So what's an index? An index gives us the idea of how many times a particular number is multiplied. How many times a particular number is multiplied or can be multiplied. For instance, if I have 4, 4 will simply be equal to 2 times 2, is that not? So if 4 is equal to 2 times 2, it means that 2 is multiplied twice. We said an index gives us an idea of how many times a number is being multiplied. So if I pick 4 being equal to 2 times 2, I don't want to write it as 2 times 2. There's another way I can write it. It will be 2 index 2. So an index is also a superscript. An index is what? A superscript, because of the position in which it is written. There are 3 positions or 4 positions I can write in number. So I'm going to do an extension of your thoughts here. Let's say I have A. I can write here, I can write here, and I can write here. Okay, let's just say 3 points. If I write here, it is called coefficient. If I write here, it is called a subscript. If I write here, it is called a superscript. So this position is what is of importance to me, because this is what I call my index. So for this particular topic, we are concerned with writing it here. That's why you hear some foreign teachers will tell you 2 index. But here we use 2 raised to the power of words. But the technical word is index. So 2 index 2 means 2 multiplied twice. So understand the meaning of index, its application, and what it does in a problem. So with that, I'll clean up this point. I'll clean up this and then go back to my work. So 4 will be equal to 2 times 2, which means 2 index 2. I can have 8. 8 will be equal to what? 2 times 2 times 2. How many times have I multiplied 2? 3 times. So this will be 2 index 3, meaning 2 multiplied 3 times. So with that, we'll clean this off and then take some examples. All right, so we will take exercise, we go to exercise 3D now. Exercise 3D. On page 17 of our text, the New General Mathematics, and it says question number 1, write the following in index form. I'll just take a few of them. Exercise 3D, number 1. It says, I'll just take number 1E. It says 6. How many times? 1, 2, 3, 4, 5, 6, 7. If I'm right, 6 times 6 times 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6, 7. So 6 is multiplied 7 times. It will mean that the answer is what? 6 index 7, or 6 raised to the power of 7. That's what that means. Then let me take another one. Let's say I'll take C, for instance. 10 times 10 times 10 times 10 will mean 10 multiplied 4 times. 1, 2, 3, 4. So index gives us an idea, or gives us the idea of how many times a given number is being multiplied, right? Okay, with that sorted out, we will now go to question 3, which will essentially test the concept we want to handle. It says express the following as a product of primes. Now, when the word primes is used, it also means prime numbers or prime letters. So primes in index form. Express the following as product of primes in what? Index form. So I'll just pick a few of the examples here. I'll look at A, which is 24. I'll look at G, which is 360. I'll look at N, which is 1404. And I'll look at P, which is 7,290. I'll just pick up those four rather, and then we will get to work. All right, I just itemized the questions I want to solve. So I'm going to roll my board. I'm going to do question A, which is 24. And I'm going to do question G, which is 360. All right, so let's start. Remember I said that this is the reason why we use this method. This is the best method for solving this, except the other methods we can use, and then when we get to exam preparation mode, maybe what we're doing end of term or whatever, there's really a method I teach you. I can help you pick these things out quickly. You, in an exam setup, you may not necessarily have to do all of this, even if it's a theory question. There are other methods we can use, but let's stick to this just to warm us up to what we're doing. Now, 24 is an even number, so I have to divide with 2. Still an even number. Still an even number. Odd number, the next prime number I have is what? 3. So maybe I should remind you of the prime numbers again. So I'll just write them down here so that we don't forget. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Let's just stick to those ones and trust that we wouldn't exceed that and those numbers there. So at the end of the day, what you're going to have will be what? Watch. 24 will be equal to what? 2 has occurred how many times? 3 times. So it will be 2 raised to the power of 3 times. 3 has occurred once, 3. Now, whether you write 3 or 3 to the power of 1, it means the same thing. You can write it as 3 or 3 to the power of 1 to mean the same thing. All right. Let's come to 360. It's an even number. And remember we said that 2 is the only prime number that is even. So we look for prime factors now. 2 will give me 180 here. You must be good at your division here. 2 will give me 90 here. 2 will give me 45 here. Now it's an odd number. So after 2, what's the next one I can use? I can use 3. Please don't go to 5. Use 3 first. This will give me 15. 3 again, that will give me 5. And then I'll try 5, which will give me 1. So next thing I'll do is to say 360 equal to 2 has occurred what? 1, 2, 3. 3 has occurred twice. And 5 has occurred once. So this is what your final answer would look like. All right, so let's start. I'm going to rule this. And I'm going to start with 2. 2 will give me 702 or 702. Sorry about that. I'll try 2 again. It will give me 3, 5, 1. At this point, it's an odd number, so I can't use 2 again. The next thing I'm going to try will be 3. 1, 1, 7. I try 3 again. 3, 9. I try 3 again. 1 and 3. It's 13. And if you discover 13 is a prime number, so I'll just use the prime factor 13 to divide that, and that will be 1. So at the end of the day, I will now write 1,404 equal to, I start with the first number I'm seeing, 2. How many of it am I seeing? 2. I go to 3. How many of it am I seeing? 3. I go to 13. How many of it am I seeing? It's just 1. And so I've cleared that one out. It's as simple as that. There's no big work there. Then I come to this one. What will I do here? I'll divide with 2. If I divide with 2, what do I have? 3, 6, 8 or 9. I will have what? 4. That will be 5. I've exhausted that. So the next thing I'm going to try will be what? 3. 1, 2, 1, 5. What else can I try? I can try 3 again. 4. Now, 3 into 1, it cannot. So I will drop a 0. This way you have to be careful. Hear this. If 3 is dividing a 4-digit number, your answer must be a 3-digit answer. Come again. If 3 or a 1-digit number is dividing a 3-digit number, rather, if a 1-digit number is dividing a 4-digit number, your answer will likely be a 3-digit number. So if you're getting 2 digits, check where there's something missing. So 3 divide 12 will give me 4. 3 divide 1, it cannot. So you drop a 0, and then you have a carry of 1 here. 3 divide 15 will give me what? 5. I try 3 again. 1 into 10 will give me 3. Into 15 will give me what? 5. You see here that your knowledge of multiples become very important. How well you can read your 2 times, 3 times, 4 times becomes very, very important in this course. Now the next one will be 3. This will give me 4. Carry of 1. That will be 5. I try again. 3. This will give me 1. Into 15, that will give me 5. I try again. This will give me what? 5. And 5 here will give me 1. So you see that I have a clear picture of what it should look like. So I'll come here. 7290 will be equal to what? I have just 1, 2 times. I have 3. How many can I see? 1, 2, 3, 4, 5, 6 times. I have 5. And that settles out the problem. And that's that for prime, writing out numbers in terms of their prime factors. And then in our next class, we will go into the concept of common factors. But just like a teaser, the word common will suggest that I am comparing. The word common will suggest that I am comparing. And when you compare, it means you're comparing at least 2 things. So anytime you hear the word common factors, common multiples, it means you're comparing. So in our next class, we'll be looking at how we compare factors and perhaps how we compare multiples. I'll leave it for now, and I'll trust you have a wonderful day. Thank you. Don't go